Hello, in this lecture we'll answer two questions. The first question, we'll find out the radius of this circle that blocks quadrilateral ABCD. And in the second question, we'll find out the area of this shaded region. So we'll start with the first question. In the drawing, we have quadrilateral ABCD that is described by this circle. Side AD equals to 6 units in Islam. Side DC equals to 5 units in Islam, side BC equals to 4 units in Islam, and finally side AB equals to 4 units in Islam, and our task is to find out the radius of this circle that blocks quadrilateral ABCD. So first of all, we'll join points B and D together by straight line. And we define this is again DBC or BCD. We define this again as alpha. Quadrilateral ABCD is a cyclic quadrilateral because of the fact that all of its four vertices A, D, C, and B lie on the circle itself. Therefore, quadrilateral ABCD is a cyclic quadrilateral. And we have a rule that says that the sum of the two opposite angles in a cyclic quadrilateral is equal to 180 degrees. In the drawing, we have this quadrilateral that is described by this circle because of the fact that all of its four vertices lie on the circle itself. The sum of those two opposite angles equals to 180 degrees. That is to say, x plus y equals to 180 degrees. Likewise, the sum of those two opposite angles also equals to 180 degrees. That is to say, a plus b equals to 180 degrees. So we can implement the rule in our drawing. Because of the fact that quadrilateral ABCD is a cyclic quadrilateral, the sum of those two opposite angles must be equal to 180 degrees. That is to say, alpha plus the size of this spin circle must be equal to 180 degrees. Therefore, this spin circle must be equal to 180 degrees minus alpha. Well, because 180 degrees minus alpha plus alpha is 180 degrees, that is the sum of those two opposite angles inside quadrilateral ABCD. Therefore, this spin circle must be equal to 180 degrees minus alpha. So in the next step, we'll implement the law of cosines on both triangles. We'll implement the law of cosines on this green triangle ABD. And in the next step, we'll implement the law of cosines on this lower triangle, triangle BDC. So I keep clicking on the law of cosines. The law of cosines is true in any triangle, so this is a triangle ABC that could be any triangle. This triangle BAC is equal to theta degrees in size. Side AB equals to A units in Islam, side DC equals to B units in Islam, side BC equals to C units in Islam. And according to the law of cosines, this triangle ABC, that could be any triangle, the following equation is true. C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So I can implement the law of cosines. This great triangle ABD. So according to the law of cosines, this great triangle ABD, the following equation is true. BD square equals to AB square plus AD square minus 2 times AB times AD times cosine 180 degrees minus theta times cosine 180 degrees minus alpha. And again, according to the law of cosines, this great triangle ABD, the following equation is true. BD square equals to AB square plus AD square minus 2 times AB times AD times cosine 180 degrees minus alpha. We have the trigonometric identity that says that cosine 180 degrees minus alpha equals to minus cosine alpha. Therefore, we can substitute cosine 180 degrees minus alpha in this equation 1 by minus cosine alpha. We will do it now, we get that BD square, according to equation 1, BD square equals to AB square. AB is 3, therefore AB square is 3 squared, that is 9. Plus AD square. AD is 6, therefore AD square is 6 squared, that is 36. Minus 2 times AB is 3 times AD is 6 times cosine 180 degrees minus alpha. And cosine 180 degrees minus alpha is minus cosine alpha, so we substitute cosine 180 degrees minus alpha by minus cosine alpha. So in this expression we have minus times minus is plus. So this expression in total is a positive expression. So in total we found out that according to equation 1, BD square equals to 9 plus 46 is 45. Here it is a positive expression. Minus times minus is plus, which is plus 2 times 3 is 6, and 6 times 6 is 36 times cosine alpha. So in total, according to equation 1, if we found out that BD square equals to 45 plus 36 cosine alpha. So in the next step, we will implement the law of cosines, this lower triangle BDC. According to the law of cosines, the lower triangle ABD, and this is actually the lower triangle BDC, the following equation is true. BD square equals to BC square plus DC square minus 2 times BC times DC times cosine alpha. And again, according to the law of cosines, in this lower triangle BDC, the following equation is true. BD square equals to BC square plus DC square minus 2 times BC times DC times cosine alpha. BD is the missing side, so we leave it as it is, so it is BD square equals to BC squared. BC is 4, therefore BC squared is 4 squared, it is 16, plus DC squared. DC is 5, therefore DC squared is 5 squared, this is 25, minus 2 times BC is 4, times DC is 5, times cosine alpha. So if you want that according to equation 2, PD squared equals to 16 plus 25 is 41, minus 2 times 4 is minus 8, times minus 5 is minus 40, times cosine alpha. So we have two different equations for BD squared, equation 1 and equation 2. Therefore, we get equation 3 that says that BD squared according to equation 1 must be equal to BD squared according to equation 2. And again, equation 3 states that BD squared according to equation 1 must be equal to BD squared according to equation 2. Very simple equation. So BD squared according to equation 1 equals to 45 plus 36 times cosine alpha. It must be equal to BD squared according to equation 2. BD squared according to equation 2 equals to 41 minus 40 times cosine alpha. So total according to equation 3, we have found that 45 plus 36 times cosine alpha equals to 41 minus 40 times cosine alpha. So here we subtract 41 from this equation 3. So here 41 gets cancelled, and on the other side of the equation we have 45 minus 41 is 4. So according to equation 3, we found out that 4 plus 36 times cosine alpha equals to minus 40 times cosine alpha. So here we let 40 times cosine alpha to this equation. So 40 times cosine alpha minus 40 times cosine alpha is 0. So this side of the equation we have nothing, that's to say 0. While on the other side of the equation we have 4 plus 36 cosine alpha. 40 times cosine alpha plus 26 cosine alpha equals to 76 cosine alpha. So if you want to know that 4 plus 76 times cosine alpha equals to 0. Here we subtract 4 from this equation, equation 3, and get it. So in this one of equation 4 we get cancelled, and we have only if 76 times cosine alpha, while on the other side of the equation 0 minus 4 is minus 4. So if you want to know that 76 times cosine alpha equals to minus 4. Here we will divide this equation 3 by 76 and get it according to equation 3 cosine alpha equals to minus 4 over 76. minus 4 over 76 is equal to minus 0.0526. So today we found out that according to equation 3, cosine alpha equals to minus 0.0526. Okay, now. So according to equation 3, we found out that cosine alpha equals to minus 0.0526. Cosine alpha equals to minus 0.0526. So in order to find out the value of alpha itself, we operate on the result of this equation, the opposite function of cosine, that is inverse of cosine of minus 0.0526. So about the opposite function of cosine, that is inverse cosine of the result. And this way we get the value of alpha itself. So inverse cosine of minus 0.052 is equal to alpha, and alpha equals to 93.017 degrees in its size. So okay, this is again alpha is equal to 93.017 degrees in its size. Therefore, this angle equals to 180 degrees minus alpha. So it is 180 degrees minus 93.017. This is roughly equal to 86.98 degrees. And again, 180 degrees minus alpha is 93.017 degrees is equal to 86.98 degrees in its size. So now we can find out the value of BD itself. So we have the equation that says that BD squared equals to 41 minus 40 times cosine alpha. This BD squared equals to 41 minus 40 times cosine alpha. Question according to equation 2, BD squared equals to 41 plus 40 times cosine alpha. So BD squared, with equation 2, BD squared equals to 41, and we have minus 40 times cosine alpha. So this cosine alpha is 93.017 degrees in size. So in total we found out that BD squared equals to, according to equation 2, BD squared equals to 41 minus 40 times cosine 93.17. Roughly cosine 93.017 is equal to minus 0.0526. So total this expression equals to BD squared equals to 41 and minus 40 times minus 0.0526 equals to 2.105. So it is plus minus times minus is plus, so it is plus 2.105. So total BD square equals to 41 plus 2.105. That is to say, BD square, only to equation 2, BD square equals to 43.105. So here we take a root out of this equation, and when we get that BD, only to equation 2, BD equals to the square root of 43.105, that equals to 6.565. And again, if you want to know that BD equals to 6.565 units in its length. Again, BD equals to 6.565 units in its length. It is 6.565 units in its length. In the next step, we will implement the law of sines on this lower triangle BDC. Spin again on the law of sines. The law of sines is true in any triangle. So actually, this is triangle ABC that could be any triangle. This is angle BAC. This is equals to capital A decreasing in size. This is angle ABC. This is equals to capital B decreasing in size. Finally, this is angle ACB. This is equals to capital C decreasing in size. Likewise, AB equals to 2 units in its length. AC equals to B units in its length. BC equals to A units in its length. This is triangle ABC that is described by this circle. The radius of this circle is R. So according to the law of sines that is true in any triangle, this triangle ABC that is described by this circle, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. And again, according to the law of sines, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So we can implement the law of sines, this lower triangle BDC. According to the law of sines, this lower triangle BDC, the following equation is true. BD over sinus alpha, BD over sinus alpha equals to 2R. And R is the radius of this circle, that is the radius that we are looking for. Okay, again, R is the radius of this circle, that is the radius that we are looking for. Actually, we can implement the law of sines in the lower triangle BDC because of the fact that the lower triangle BDC is described by this circle. Why? Because of the fact that all the 3 vertices of this triangle BDC lie in the circle itself. This is vertex B, vertex C, and vertex C. These are all lines of the circle itself. Therefore, this is the triangle BDC, the lower triangle BDC is described by this circle. For this reason, you can implement the law of sines in its full version. This is to say BD or sin alpha equals to 2r, and now the roots of this circle that we are looking for. But we already found out that BD equals to 6.565 over sinus alpha. Alpha is 93.017, so it is sinus 93.017 equals to 2r. So we found out that according to the law of sines, in the lower triangle BDC, the following equation is to 6.565 over sinus 93.017 degrees equals to 2r, and r is the roots of the circle that we are looking for. So we have 6.565 over sinus 90 degrees, 93.017 degrees. In total, the value of this expression is equals to 2r. So the value of this expression is actually 6.53 is equals to 6.5745. So those two sides of the equation are equal to each other. That is to say 6.5745 equals to 2r. Here we divide this equation by 2. Again, that r, that is the radius of the circle that we are looking for, is equal to 3.287 units in Israel. And again, we found out that the radius of this circle, that is the radius that we are looking for this question, is equal to 3.287 units in Israel. So we finish to answer on the first question. In the next step, I'll present you the second question and answer the second question of this lecture. The second question or task is to find out the area of this shaded region. So in the drawing, this is the big quadrilateral ABCD. AD equals to 9 units in Islam, side DC equals to 8 units in Islam, this is side BC, this equals to 7 units in Islam. Again, our task. And we also know that those three angles, they're all right angles. 1, 2, 3, they're all right angles. Again, our task is to find out the area of the shaded region. So first of all, we join points A and Q together by a straight line. Likewise, we join points B and Q together by a straight line. Here we can implement rule 3. AB is one side of quadrilateral ABCD, therefore it is definitely a straight line. So if we focus on the lower side of the straight line AB at point B, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles from one side of a straight line is equal to 180 degrees. So at the lower side of the straight line AB at point B, here the sum of the angles must be equal to 180 degrees. That's 180 degrees. That is to say, 90 degrees plus this mid-circle in total must be equal to 180 degrees according to Olympiad. Therefore, this mid-circle must be equal to 90 degrees in its size. In the next step, we prove that the shaded triangle QBP can point to this right triangle AQP according to side angle side law. Repeat again, we prove that this is the right triangle APQ that is converted to this shaded triangle QPB according to side angle side rule. So writing down, we have to prove that this is the right triangle APQ. We also know that AP equals to PB according to what is given us the question. So we prove that the right triangle AQP can go into this right triangle QPB according to side angle side rule. We have to prove that this is the right triangle APB. And again, this is the right triangle APB. It is the right triangle APQ. And we have to prove that this is the white triangle AP, the white right triangle APQ. We have to prove that the white right triangle APQ can go into this shaded right triangle PBQ. So what those two white triangles can go into each other. First of all, it is given as a question that AP equals to PB. So side AP of the white triangle PB is equal to side PB according to what is given as a question. And again, side AP of the white triangle APQ the white triangle APQ is equal to side PB of the shaded triangle PBQ according to what is given as the question. In addition, those triangles are both right angles and therefore they are equal to each other. So actually, this is again APQ of the right triangle APQ, and it is equal to this angle, this angle QPB of the shaded right triangle QPB. And again, if you know that angle APQ of the right triangle equals to angle QPB of the shaded right triangle, they are both equal to 90 degrees and therefore they are equal to each other. And finally, PQ is a common side that belongs to both triangles, so we can find out that PQ equals to itself is a common side that belongs to both triangles. So PQ equals to itself is a common side that belongs to both triangles. Again, PQ equals to itself is a common side that belongs to both triangles. So if you found out that those two right triangles can go to each other according to side angle side rule. So I can now prove that the right triangle APQ can point, this is the sum of can point, to the shaded right triangle PBQ according to side angle side rule. That is to say, if we prove that those two sides and the angle that is included between those two sides in this right triangle QPB, of course, will equal to those two sides and the angle that is included between those two sides in this shaded right triangle QPB. Therefore, those two right angles can run to each other according to side, angle, side, or again we have those two sides, and the angle that is included between those two sides in this right angle corresponding equal to those two sides, and the angle that is included between those two sides in this shaded right angle. Therefore, those two right angles can run to each other according to side, angle, side rule. And from the fact that they can run to each other, we realize that their angles must be also equal to each other in their sizes. That is to say, the area of this triangle APQ must be equal to the area of this shaded right triangle QPB. So it is known the area of this right triangle QPA is equal to the area of this shaded right triangle QPB. And because if two triangles can go into each other, they must have also the same areas. Okay, so the right triangle QPA, the right triangle QPA equals to the area of the shaded right triangle QPB because they can go into each other. In addition, we can conclude from the fact that those two right triangles can go into each other that side AQ equals to side QB. AQ equals to QB. According again, AQ equals to QB. According to the rule that says that corresponding sides and right triangles are equal to each other, those two right triangles can go into each other, therefore their corresponding sides must also equal to each other in their lengths. That is to say, AQ equals to QB. Why AQ is the corresponding side to QB? Because AQ is located in front of this right angle, likewise QB also is located in front of those two right angles, of this right angle. Therefore, AQ is the corresponding side of QB. So AQ equals to QB. Here, let's square this equation. We get that AQ square equals to QB square. In this right triangle AQD, AQ square equals to AD square plus DQ square according to the Pythagoras theorem. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, in this right triangle AQ square equals to AD square plus DQ square. So AQ square equals to AD square plus DQ square. But again, AQ square equals to AD square plus DQ square according to the Pythagoras theorem, and DQ square equals to QB square. QB or BQ is the hypotenuse of this shaded right triangle BQC. So according to the Pythagoras theorem, in this shaded right triangle BQC, BQ square equals to BC square plus CQ square. Again, BQ square equals to BC square plus QC square. So if you know that AD square plus DQ square equals to BC square plus QC square. Here we define DQ as x. We know that DC equals to 8 units in itself. Therefore, the missing side QC must be equal to DC divided 8 minus x minus dB. Again, the QC equals to DC minus DQ. This is to say QC equals to DC divided 8 minus DQ, this is x. So it is in total QC equals to 8 minus x units in itself. So here we can we substitute dq this equation by x. dq equals to x, therefore dq square is x squared. We have AD squared. AD is 9, therefore AD squared is 9 squared, that is 81. So in total, in this side of the equation, we have 81 plus x squared equals to bc squared plus qc squared. bc is 7, therefore bc squared is 7 squared, that is 49. Plus qc squared. qc is 8 minus x, therefore qc squared is 8 minus x squared. So in total, we found out that 81 plus x squared equals to 49 plus 8 minus x squared. So here we'll open the brackets of this side of this equation and get that 81 plus x squared equals to 49 plus 8 minus x squared. 8 minus x squared equals to, according to the algebraic identity, they say that a minus b squared equals to a squared plus b squared minus 2 times a times 3. We get that 8 minus x squared equals to 8 squared, that is 64 plus x squared. Minus 2 times 8 times x is minus 16x. So in total we found out that 81 plus x squared equals to 49 plus 64 is 113 plus x squared minus 16x. So here we have x squared on both sides of the equation, so x squared can cancel. After cancel x squared, on this side of the equation we have only if 81. On the other side of the equation we have 113 minus 16x. So in total, if you all know that '81 equals to 113 minus 16x. So here we add 16x to the equation. I get that here 16x will get cancelled, and we have only 113. While on the other side of the equation we have 81 plus 16x. So in total, we found out that 81 plus 16x equals to 113. Here we subtract 81 from this equation. So here 81 gets cancelled, and we have only 16x. While on the other side of the equation, 113 minus 81 is 32. So in total, we found out that 16x equals to 32. Here we divide this equation by 16. We get that x equals to 32 over 16 is 2. X equals to 2 units in its length. X equals to 2 units in its length. QC equals to 8 minus x. 8 minus x is 8 minus 2, that is 6. We already found out that because of the fact that the right triangle APQ can go into the shaded right triangle PQB, they must have also the same areas. So if we define the area of this right triangle QPB as A, then the area of this right triangle PQB must be also equal to A. Again, if we define the area of this right triangle APQ as A, then the area of this right triangle QPB must be also equal to A, because they have the same areas because of the fact that they can go into each other. What is the area of this right triangle ADQ? The area of the right triangle ADQ equals to the base, that is 2, times the height of the base, that is 9 over 2. So it is 9 over 2, 9 times 2 over 2. 9 times 2 over 2 is 9. And it is the base times the height over 2. So it is 2 times 9 over 2, that is 9 square units in its size. Likewise, what is the area of this shaded right triangle BQC? The area of the shaded target BQC equals to the base QC, that is 6, times the height CB, that is 7 over 2. So it is 6 times 7 over 2. 6 times 7 is 42, and 42 over 2 is 21. So the area of this shaded target BCQ equals to 21 square meters inside, and the area of this target ADQ equals to 9 square meters inside, and the area of those two targets are both equal to 8 degrees, A square units in their sizes. So in total, the area of this quadrilateral ABCD must be equal to 9 plus A plus A plus 21. The area of quadrilateral ABCD in total is equal to the sum of those three components that it consists of. It's actually 9 plus A plus A plus 21. 9 plus 21 is 30. A plus A is 2A. So I should find out that the area of this quadrilateral ABCD is equal to 30 plus 2A square meters inside. What is the definition of this quadrilateral ABCD? Because of the fact that quadrilateral ABCD has those two parallel sides, it is defined as a trapezoid. Because a trapezoid is a quadrilateral with one pair of parallel sides. Why side AD is parallel to side BC? So we can implement rule 20. Now we're going. According to rule 20, the sum of two one-sided angles is equal to 180 degrees. If the sum of two angles is equal to 180 degrees, then they must be located between parallel lines. Going here, line A and line B, this is the line C that cuts those two lines A and B, those 2 points. Those are the two angles that are defined as one-sided angles. So if we know that alpha plus beta equals to 180 degrees, then they must be located between parallel lines. That is to say, line A is parallel to line B. Likewise, if we know that gamma plus delta equals to 180 degrees, then they must be located between parallel lines. That is to say, line A is parallel to line B. So we can implement rule 20 now going. 90 degrees plus 90 degrees is equal to 180 degrees. So the sum of those two one-sided angles is equal to 180 degrees. Therefore, AD and BC, therefore those two one-sided angles, the sum of them is equal to 180 degrees, must be located between parallels. That is to say, AD is parallel to BC. Therefore, in quadrilateral ABCD, we have one pair of parallel sides. That is to say, AD is parallel to BC. Therefore, quadrilateral ABCD is defined as a trapezoid, because it has one pair of parallel sides. What is the area of a trapezoid? This is trapezoid. Why it is a trapezoid? Because line A is side A is parallel to side B. The height of the base is h. So the area of this trapezoid equals to the sum of its two parallel bases, that is to say A plus B, times the height h over 2. And again, the area of the trapezoid equals to the sum of the two parallel bases, that is to say it is A plus B, times the height to the base h divided by 2. So the area of this trapezoid ABCD, according to the new formula, must be equal to the sum of its two parallel bases. That is to say it is AD plus BC. AD is parallel to BC according to rule 20. So the area of trapezoid ABCD equal to the sum of its two parallel bases, that is AD plus BC, times the I to the base. The I to the base must create an address with the base. DC definitely creates an address with those two bases. Therefore, DC is the I to the base. Divided by 2. And to we found out that the area of this trapezoid ABCD equals to the sum of the two parallel bases, that's actually AB plus DC. This is AD plus BC. AD plus BC times the I, that is DC, over 2. So total, the area of trapezoid ABCD equals to AD is 9 plus BC is 7 times the I, DC is 8 divided by 2. So total, we found out the area of this trapezoid ABCD equals to 9 plus 7 times 8 over 2. 9 plus 7 is 16. 8 over 2 is 4. 16 times 4 is 64 square in size. So the area of trapezoid ABCD equals to 64 square in size. So quadrilateral ABCD is a trapezoid. We just like to find out that the area of trapezoid ABCD is 64. This is to say 30 plus 2a equals to 64. 30 plus 2a equals to 64. Here we subtract 30 from this equation. Again, that here 30 gets cancelled, left only with 2a. Then on the other side of the equation we have 64 minus 30 is 34, so 2a equals to 44. Here we divide this equation by 2, and we get that a equals to 34 over 2 is 17. A equals to 17. A equals to 17. 17 is equivalent in size. Likewise, A equals to 17 is equivalent in size. So the area of the shaded region equals to A plus 21. And again, the area of the shaded region equals to A plus 21. Because again, the area of the shaded region equals to A plus 21. A is 17, so it is 17 plus 21, that is 38 square in size. So total we found out that the area of the shaded region, that is the area that we're looking for. The area of the shaded region equals to 38 square in size. So we finish with the second question. In the next step, we summarize the lecture. We start with the repetition of the solution of the first question, and then build on the solution of this second question. In the first question, our task is to find out the radius of this circle. So in the drawing, we have quadrilateral ABCD that is described by this circle. But again, we have quadrilateral ABCD that is described by this circle. Side AB equals to 4 units in itself, side AD equals to 6 units in itself, side DC equals to 5 units in itself, and finally side BC equals to 4 units in itself. And our task is to find out the area of this circle that blocks quadrilateral ABCD. So first of all, we join points B and D together by straight line. Join points B and D together by straight line. We define this is angle BCD as alpha. Therefore, this angle must be equal to 180 degrees minus alpha. According to the rule that says that the sum of the opposite angles in a cyclic quadrilateral is equal to 180 degrees. So alpha plus this angle in total must be equal to 180 degrees. Therefore, this angle must be equal to 180 degrees minus alpha. 180 degrees minus alpha plus alpha is 180 degrees. That is the sum of the angles. This of those two opposite angles is inside this cyclic quadrilateral ABCD. According to Rule 20. Okay, so in the next step, we implemented the law of cosines. First of all, in the green upper triangle ABD, and then in the lower triangle BDC. So please click on the law of cosines. This is triangle ABC that could be any triangle. This angle BAC equals to 30 degrees inside, side AB equals to 1 unit inside, side AC equals to B units left, side BC equals to 3 units left. So this triangle ABC that could be any triangle, the following equation is to C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So we can implement the law of cosines in the green triangle, upper green triangle, ABD. According to the law of cosines, this green triangle ABD, the following equation is to BD square equals to AD square plus AB square minus 2 times AB times AD times cosine 180 degrees minus alpha. Again, this green triangle ABD, according to the law of cosines, the following equation is to BD square equals to AB square plus AD square minus 2 times AB times AD times cosine 180 degrees minus alpha. We have the trigonometric identity that says that cosine 180 degrees minus alpha equals to minus cosine alpha. Therefore, substitute cosine 180 degrees minus alpha here by minus cosine alpha. So therefore, if you know that BD square equals to AB square, therefore AB square square that is 9. Plus AD square, AD 6, therefore AD square is 6 square, that is 36, minus 2 times AB, that is 3, times AD, that is 6, and times cosine 180 degrees minus alpha, this is minus cosine alpha, according to this trigonometric identity. So this expression, in total, it is a positive expression, because minus times minus is plus. So in total, if you found out that BD square equals to 9 plus 36 is 45, and it is plus 2 times 3 is 6, and 6 times 6 is 36 cosine alpha. So in total, according to equation 1, if you found out that BD square equals to 45 plus 36 times cosine alpha. Likewise, we implemented the law of cosine in this lower triangle BDC. According to the law of cosines, in this triangle BDC, the following equation is to BD square equals to DC square plus BC square plus 2 times DC times BE times cosine alpha. Again, BD square equals to DC square plus BC square minus 2 times DC times BC times cosine alpha. Okay, again, this lower triangle BDC, according to the law of cosines, the following equation is to BD square equals to BC square minus DC square minus 2 times AB times DC times cosine alpha. BD is the missing side, so it is. equals to BC squared. BC is 4, therefore BC squared is 4 squared, that is 16, plus DC squared. DC is 5, therefore DC squared is 5 squared, that is 25, minus 2 times BC, that is 4 times DC, that is 5 times cosine alpha. So in total, we know that BD squared equals to 16 plus 25 is 41. We have minus 2 times 4 is minus 8. Minus 8 times 5 is minus 40 times cosine alpha. So in total, according to equation 2, we know that BD squared equals to 41 minus 40 times cosine alpha. But according to equation 1, we only found out that BD squared equals to 45 plus 36 times cosine alpha. So we have two different equations for BD squared. Therefore, again, the equation 3 that says that BD squared according to equation 1 must be equal to BD squared according to equation 2. Very simple equation. BD squared according to equation 1 equals to 45 plus 36 times cosine alpha. It must be equal to BD squared according to equation 2. BD squared according to equation 2 equals to 41 plus 40 times cosine alpha. So total according to equation 3, I should find out that 45 plus 36 times cosine alpha equals to 41 plus 40 times cosine alpha. So here we have we subtract 41 from this equation, so here 41 will get cancelled. When on the other side of the equation, we have 45 minus 41 is 4. Here 45 minus 41 is 4, plus 36 times cosine alpha equals to minus 40 times cosine alpha. So here we have 40 times cosine alpha to this equation. So here this side of the equation we left with nothing, that is to say 0, and on the other side of the equation we have 40 times cosine alpha plus 36 cosine alpha is 76 cosine alpha plus 4. So total according to equation 3, I should find out that 4 plus 76 times cosine alpha equals to 0. So here subtract 4 from this equation, so here 4 will get cancelled. We have to leave 76 times cosine alpha, on the other side of the equation, 0 minus 4 is minus 4. So total according to equation 3, we found out the 76 times cosine alpha equals to minus 4. So here we divided this equation by 76 and found out that cosine alpha equals to minus 4 over 76. Minus 4 over 76 is minus 0.0526. So in total according to equation 3, we found out that cosine alpha equals to minus 0.0526. And in order to find out the value of alpha itself, we operated the inverse function of cosine on the result. Actually found out that inverse function of cosine on the result is minus 0.0526 is equal to alpha. And the value of the inverse function of cosine on minus 0.0526 is 93.017. So if you found out that angle alpha, the size of angle alpha is 93.017 degrees. But according to equation 1, we already found out that BD squared equals to 41 minus 40 times cosine alpha. So BD squared according to equation 2 equals to 41 minus 40 times cosine alpha, and alpha is 93.017 degrees. So total, if you found out that BD squared equals to 41 minus 40 times cosine 93.017 degrees. The value of cosine 93.017 is equal to 40 times cosine 93.17 degrees is in total 2.105. So total according to equation 2, if you found out that BD squared equals to 41 plus 2 times 105. So BD squared equals to 41 plus 2.105 is 43.105. So total, if you found out that BD squared equals to 43.105, here we took a root out of the equation, and we found out that BD equals to the square root of 43.105, that's actually 6.565. So that, if you found out that BD equals to 6.565 units in this length. This is side BD equals to 6.565. The next step, implemented the law of cosines in this lower triangle BDC. So I put quickly on the law of cosines, the law of sines, of course. The law of sines is drawn in a triangle. This is a triangle ABC that could be an triangle. The size of angle BAC is capital A degrees. The size of angle ACB is capital C degrees. The size of this angle ABC is capital B degrees. Likewise, AB equals to C unit sinister, AC equals to B unit sinister, BC equals to A unit sinister. And we know that triangle ABC is inscribed by this circle. So according to the law of sines in its full version, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. And again, according to the law of sines in its full version, this is another drawing. The following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. So we can implement the law of sines in the lower triangle BDC in its full version. Why? Because of the fact that the lower triangle BDC is inscribed by this circle. Why? Because of the fact that all the three vertices of this lower triangle BDC lie on the circle itself. Therefore, it is inscribed by this circle. Therefore, we can implement here the law of sines in its full version. The law of sines in its full version is as follows: BD over sinus alpha equals to 2R. And now the radius of this circle that blocks triangle ABC. That blocks this triangle BDC, that is the radius that we are looking for in our question. In total, according to the law of sines, if we implement the law of sines in this triangle BDC that is described by this circle, the following equation is to BD over sinus alpha equals to 2R. We only found out that BD equals to 6.56, and sinus alpha is 93.017, so it is sinus 93.017. The value of this expression is 6.5745 equals to 2R. Those two sides of the equation are equal to each other. That is to say, in total, I should hold on that 6.5745 equals to 2R. Here we divide this equation by 2, we found out that I equals to 0.5745 over 2. This is 3.287 units in its length. And again, in total, I should hold on that the radius of this circle, that is the radius that we are looking for in this question, is equal to 3.287 units in its length. So finish our print on the first question, the solution of the first question, and the next step, print on the solution of the second question. In the second question, our task is to find out this shaded region. So in the drawing, we have the big quadrilateral ABCD. Side AD equals to 9 units in its length. We also know that AP equals to PB. Side BC equals to 7 units in its length. And finally, side DC equals to 8 units in its length. Again, our task is to find out the area of this shaded region. So, first of all, we join points Q. We join points B and Q together by side line, and we join points A and Q together by side line. This is the missing angle. According to all three, this missing angle equals to 90 degrees in size. All three said that the sum of the angles on one side of the side line is equal to 180 degrees. So the sum of the angles of the lower side of the side line AB at point P must be equal to 180 degrees. This is the right angle. The right angle plus this missing angle in total must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 90 degrees inside. So in the next step, we prove that the right triangle APQ can go to this right shaded right triangle PQB according to side against side rule. So what those two right angles can go into each other. First of all, AP equals to PB according to what is given in the equation. In addition, we know that those two angles are both right angles that are therefore equal to each other. And finally, PQ is the common side that belongs to both angles, so we can write down that PQ equals to itself is the common side that belongs to both angles. So in total, if you found out that those two right angles can point to each other according to side angle side 1. That is to say, if you prove that those two sides and the angle that is present between those two sides, this right angle APQ corresponds equal to those two sides, and the angle that is present between those two sides is shaded triangle QPB. Therefore, those two right angles can point to each other according to side angle side 1. Again, we have those two sides, and again, the angle that is present between those two sides in this right angle corresponds equal to those two sides, and the angle that is present between those two sides in this shaded triangle PQB. Therefore, those two right angles can point to each other according to side angle side 1. And again, if you want to know that the white triangle in PQ can point, this is the side of curve white, to the shaded triangle PBQ according to side angle side 1. From the fact that those two right angles can point to each other, we know that they must have also the same areas. So if we find the area of this, right triangle in PQ as A, then the area of this shaded right triangle PBQ must be also equal to A divided in size because they have the same areas because of the fact that they can point to each other. So we defined the length of DQ as X, therefore everything minus QC must be equal to 8 minus X. And then, because of the fact that those two triangles can point to each other, we have that BQ equals to AQ. BQ equals to AQ. And again, BQ equals to AQ according to the rule that corresponding sides and right triangles are equal to each other. Those two right triangles can point to each other, therefore those two corresponding sides must be equal to each other in the rest. That is to say, AQ equals to BQ. AQ equals to BQ, so we squared both sides of the equation. Found out actually that AQ squared equals to BQ squared, QB squared. So in this right triangle AQB, according to the Pythagorean theorem, in a right triangle the sum of the opponents equals to the sum of the sides of the perpendiculars. That is to say, this right triangle AQD, AQ squared equals to AD squared plus DQ squared. Therefore, can substitute this right triangle AQ squared by AD squared plus DB squared according to the Pythagorean theorem. Likewise, in this triangle BQC, BQ squared equals to BC squared plus CQ squared. Therefore, we can substitute BQ squared by BC squared plus CQ squared. Again, substitute BQ squared by BC squared plus CQ squared. So if you want to know that AD squared plus DQ squared equals to BC squared plus AC squared. AD is 9, therefore AD squared is 9 squared, that is 81. Plus DQ squared, DQ is X, therefore DQ squared is X squared. So total AD squared plus DQ squared equals to 81 plus X squared, and it equals to BC squared plus QC squared. BC is 7, therefore BC squared is 7 squared, that is 49, plus QC squared. QC 8 minus X, therefore QC squared is 8 minus X squared. So total, this is the equation. We have BC squared plus QC squared is actually 49 plus 8 minus X squared. So total, we should all know that 81 plus X squared equals to 49 plus 8 minus X squared. So we have 81 plus X squared equals to 49 plus 8 minus X squared. 8 minus X squared equals to 8 squared, that is 64 plus X squared minus 2 times 8 times X, that is minus 16X. So total, if you want to know that 81 plus X squared equals to 49 plus 16 plus 64 plus X squared minus 16X. We have X squared on both sides of this equation, so X squared gets cancelled. And after we cancel X squared, on this side of the equation we have to only have 81, and on the other side of the equation we have 49 plus 64 is 113 minus 16x. Here we can set here of x squared, so after we can set x squared, we have to only if 81 equals to 113 minus 16x. So again, we have to only if 81 equals to 113 minus 16x. So here we added 16x to this equation, so here 16x will get cancelled, and we have to only 113, and on the other side of the equation we have 81 plus 16x equals to 113. Here we subtracted 81 from this equation, so here 81 will get cancelled, and we have to only 16x, and on the other side of the equation we have 113 minus 81 is 32. So in total, if we found out that 16x equals to 32, if that is divided the equation by 16, and if I found out that x equals to 32 over 16 is 2. So here x equals to 2, and 8 minus x is 8 minus 2, that is 6. So the area of this right triangle ADC equals to the base 2 times the height 9 over 2. 9 times 2 over 2 is 9. The area of this right triangle DQ, the right triangle DQ is equal to 9 squares in its size. Likewise, the area of this shaded right triangle BCQ equals to the base 6 times the height 7 over 2. 6 times 7 is 42. 42 over 2 is 21. So total the area of this shaded right triangle BCQ equals to 21 squares inside. The area of this right triangle ADC equals to 9 squares inside. And according to our definition, the area of those two areas are both equal to 8 squares inside because they can go into each other. So in total the area of the big quadrilateral ABCD must be equal to 9 plus A plus A plus 21. 9 plus 21 is 30, A plus A is 2A. So total the area of this quadrilateral ABCD is equal to 30 plus 2A. From one side, but from the other side, quadrilateral ABCD is a trapezoid. Why? Because it has one pair of parallel sides. Why AD is parallel to BC? Because of the fact that the sum of those two triangles is 180 degrees, therefore they must be located between parallel lines, according to Rule 20. That is why AD is parallel to BC. Therefore, quadrilateral ABCD is defined as a trapezoid because it has one pair of parallel sides. What is the area of a trapezoid? Okay, we know that the area of a trapezoid is equal to the sum of its two parallel sides. That is the basis, A plus B times the height edge over 2. Again, the area of this trapezoid is equal to the sum of its two parallel bases. Is actually A plus B times the height edge over 2. The height edge must get that with the base. Again, the area of this trapezoid ABCD equals to A plus B times edge over 2. This is the sum of the two parallel bases times the height over 2. So the area of this trapezoid ABCD must be equal to the sum of those two parallel bases, roughly AD plus BC times the height CD over 2. And again, the area of trapezoid ABCD equals to the sum of the two parallel bases, roughly AD plus BC times the height DC over 2. AD is 9, BC is 7, DC is 8. So total, again, AD is 9, BC is 7, DC is 8, so it is divided by 2. So it is 9 plus 7 is 16, and 8 over 2 is 4. So in total it is 16 times 4, that is 64. So in total, we actually found out that the area of trapezoid ABCD is equal to 64 square units in size. But we already found out that the area of the same trapezoid is actually quadrilateral ABCD equals to 30 plus 2A. And we just found out that equals to 64. So today we found out that 30 plus 2A equals to 64. Here we subtract 30 from this equation, so here 30 we get cancelled, and we have to leave 2A, but on the other side of the equation we have 64 minus 30 is 34. So 2A equals to 34. Here we divided this equation by 2, we found out that A equals to 34 over 2 is 17. Here A is 17, A is 17. So in total the area of this shaded region equals to A plus 21. area of the shaded region equals to A plus 21. Area of the shaded region equals to A plus 21. A is 17, so it is 17 plus 21 is 38. So in total, we found out that the area of this shaded region, that is the area that we are looking for in this equation, is equal to 38 square units in size. Okay, thank you very much.